Hello, we will understand the concept of intersecting nodes. So what are the intersecting nodes means? So suppose we have a linked list of say 1, 2, 3, 4, another as 2, 3, 4. So intersecting a linked list means after a given point, say after 2, both linked lists have same data. 2, 3, 4, 2, 3, 4 is same, right? So 2 is the intersecting node basically. So in this intersecting nodes, we have to give it two linked lists which will be characterized by head and head 2 and should return the pointer to this node where it is intersecting to. So that is the idea. Now let's move it to main and see how we are giving data to this function, preparing linked list, and then we will understand logic. So first we are preparing the first linked list which is characterized by head, this head, okay, and there are 5 nodes in that. 1, 2, 3, 4, 5. These 5 nodes are there. Initially they are pointing to null. They have been allocated memory using malloc, memory alloc or malloc. Okay. Now as we go down, here we are assigning each of the nodes data. So 1, 2, 3, 4 and 5 nodes get 1, 2, 3, 4, 5 value as data, and each node is connected to is next one. So there will be node like 1, 2, 3. These names also will be 1. So 1's next will be connected to 2 and 2's next will be connected to 3. Okay, like that. So that is the way we do next like assignment or connecting linked list. So here it is connecting is here data we are giving, and here we are allocating and defining. Okay. Now in all those linked lists there should be a head. So head is made equal to 1. That is what this line is doing. Head is equal to 1. So because 1 is pointing to 2, if head is made equal to 1, head will also point to 2. And same way, if you go ahead next, it can iterate over all the elements. That's what we will do. These are all things we have also seen before. Same way we are doing this for second linked list. Second linked list will also define some characteristic node head 2 and first, second, third, fourth, 4 nodes basically. We are then doing memory allocation, giving data to them, and here we are simply connecting the next of first to second, like that before we told before, right? First next will be connected to second and so on. Okay, second, and second next will be connected to third. This will be third. So this way we are connecting. Okay, this is all we know. Okay, now we will so head 2 also will become to first, like we explained before, and now we will call this intersect node function. So we'll call this intersect node function, and before that we made one node actually and given memory to it, like malloc, because this function will return a structured pointer to structure. Okay, that's why we want to make this answer also as a pointer to structure. So we made it as a pointer to structure, means node. Okay, node pointer to node. Okay, so now we have to understand what this function is doing, how it is giving intersecting element. So for that, let's delete this and move up. Okay, so now we have head and head 2. We will iterate over head 1 and head 2 So what we are doing, this is head, this is head 2. So there will be a while loop running, okay, this while loop, which will run in head, and head will go one by one to each element. So if you see this, while loop, okay, this while loop is till this point here, okay. So, and inside that there is one more while loop, is here to here. So when the while loop will run, each time head will become head next. So head will become iterate over 1, 2, 3 these nodes, okay. In between there is one more while loop, head 2, which will iterate over node first, node second, node third, okay. But when one is chosen, in between one is chosen, it will go for all first, second, third and fourth node, okay. I'll show you in a better way. So when so just thinking of in a data way, we will have 1, 2, 3, 4, okay, and 2, 3, 4 as an input we gave in the linked list. When one will be chosen, head will be chosen, it will so it will be compared to head 2 data. So one will be compared to head 2 data because head 2 is incrementing here, right, every time. So keeping head 1 first, head 1 as constant means it is not changing between this part of the loop. It will be compared to 2, 3, 1 will be compared to 1 will be compared to 2, 3 and 4, okay. So that time there will be no match. This if condition will be not satisfied. Head of data will not equal to head of data. Head of data will be 1. Head of data will continuously become 2, 3, 4 because head equal to head of 2 next. Okay. So that time 1 will not match 2, 3, 4. This if will not run at all. Next time when while will come on top here. So when it will come top, head will also become head next. So head will become 2. Okay, head will become 2. Okay. So that time head of data and obviously head of 2 next. So what we are doing? Every time we are making head of 2 as equal to temp. Temp was head 2's initial value. Why we have done this? Because see, after next operation, it will go to last. This second will go to last. So, 1 second, I'll do it again. So, 1, 2, 3, 4 and 2, 3, 4. Okay. So, after first iteration, when 1 was kept constant here, this will go to next, so it will go to 4. Okay. I write 4 here properly. Think it up as a 4 here, okay, 4. Now after this one iteration of this while loop, the head 2 has gone to 4. So next time we can't compare 2 with this 4, right? So we have to make it again 2. So that's why we are doing head 2 is equal to temp. And this we have already, before this whole while loop, we had made head 2 equal to temp to store its value beforehand. So now after each iteration of while loop, outer while loop, we will make head 2 as temp. So 1, 2, 3, 4 we compared 1 with 2, 3, 4. At when it compared to 4, last it went to head of 2 went to 4. So after next iteration of comes where head 1 become 2, this thing, we have to bring this pointer back here. So for that this head 2 temp is used, okay. Head 2 is equal to temp is used. Now when you compare, 2 will become equal to 2, okay. 2 will become equal to 2, so head data will become equal to head 2 data. So condition satisfied. So 2 equal to 2 here, but after that also intersection means that next all values should match. Correct? So when these two matched, if next values are not matching, suppose it was 6 years in between, after between 2 and 4, then 2, 3, 4 and 2, 6, 4 will not match. So this will not be intersection. So that's why we use a variable called flag. We define flag as 0 initially. So when first time match will happen, what we will do? We will raise a flag we have raised, and we will put the head data, that is this data 2 into a queue. So we put into a queue 2, okay, and we raise a flag. Now onwards, every time head data should match to head 2 data, correct? So 3 should match to 3, 4 should match to 4. If not, flag will be 0, right? If in the else of the if there is a flag 0 condition, flag 0. So that time flag will become 0. That means 2 match with 2 here at this point, okay? But 3 and 4 or in between something didn't match. So that is not intersection. Intersection is only when after a given node everything matches. So we are pushing this head data into queue because we want to get the this node back, okay, from this function. Also that should be given only when this flag is always 1, because when only after passing one time flag, flag becoming 1 time, if it again becomes 0, that means it is not matching completely after this first match, okay. So that's why what we are doing, we have pushed that point where first time match happened into a queue. So queue has now 2, okay. Now we'll go down. If flag is 1, then we will push the queue front, okay. So we'll return also queue front and we'll print also queue front. Why? Because see, it can be possible. So I'll show you why we have used the queue here. So after matching 1, 2, 3, 4 and 2, 3, 4, this condition will again be satisfied at this point also. 3 equal to 3, 4 is equal to 4, right? So that point queue will be having these values, like first time match happened, 2 was pushed into the queue, then 3 matched with 3 will also be pushed into the queue, then 4 matched with 4 here, 4 will also be pushed in the queue. But because queue have a property that first in first out, okay, it has a property of FIFO, right? So 2 was the first time where it matched, so it will give you, the queue front will give you the first time value of where it matched, and that's what we want, right? We don't want so 1, 2, 3, 4 and 2, 3, 4 is there. We don't want that fourth where this like matching last, that point to be given. We want first point where it matched to be given back. So, and also when the flag will always 1 after that. So that's why we use queue, and queue will be you use the queue dot front to get that value, and we'll see out that we can return also. Okay, when you print this statement, this program, run this program, you will see queue front will come as 2. So we'll run this once. So you are seeing here 2 and 2 is coming each time. Okay. So that means our that node is returned. Okay. That was the program. Thank you. Have a nice day.